to those who are joining us here today for this presentation. As Leanne mentioned, we're going to be talking about environmental extractions. And particularly, we're going to be talking about US EPA 3545A and US EPA 3546. So with that, let's dive in. So no matter which method you're doing here, US EPA 3545A, which is pressurized fluid extraction, or US EPA 3546, which is microwave extraction, you're doing the same types of samples and looking for the same types of compounds, okay? So the end result is the same, you just have different options to choose how you're getting there. So particularly the types of samples we're looking at are soils, clays, sediment, sludges, waste solids. And the compounds we're looking at are semi-volatile organic compounds, PCBs, your dioxins, your furans, your DROs, and I'm not going to read through that whole list, but you can see it there and what we're looking for within those soil samples. As I move forward, I'm going to just keep on talking about soil and SVOCs, because that's particularly what we looked at for this study. But keep in mind that these methods that we're talking about are applicable across the board for the sample types and compounds listed here. So now I want to take kind of a broad step back to kind of look at the spectrum as a whole. Because, why are we talking about this to begin with, right? The environmental extractions are very regulated. We have EPA methods out there that you'd probably be like, oh, there's not too much flexibility in this. But I want to talk about, techniques that we do have that can help solve the problem that's pictured here. So this pie graph was taken a few years ago and was in LCGC magazine. And it's staggering to see that 62% of our time is spent on sample preparation. Compare that to analysis, what they have is 4%. All right, that's a big difference. In the last few decades, we have come so far in analysis, right? We've made huge strides, and that's great. But it's time now for sample preparation to take those same strides. And I don't know about you guys, but typically when I'm watching a webinar or so forth, I see a lot of great data, right? And it's good, I'm glad to see that. But the sample prep slide is, well, if you have a slide, is often just glossed over. This is what we did. But the reality is sample preparation is so important, okay? If you don't do good sample preparation, you don't get good analysis. And a lot of us are still doing techniques in our lab that have been around for 125 years. There is a need to take sample preparation into the modern world. And there are some options out there today that adhere to EPA methods to help you do this. So let's now dig deeper into those EPA methods. So I just want to take a quick look on kind of the advantages or the differences between these particular methods, why you'd maybe choose one over the other, okay? So, and then up to this point, I've mentioned US EPA 3545A, which is pressurized fluid extraction. The system we have that adheres to that is our EDGE system. And then US EPA 3546, which is microwave extraction. For that method, you would use the CEM MARS 6. Okay, so from this point on, I'm going to break it out and talk about EDGE. We're talking about MARS 6. Now, the EDGE is a sequential system. Okay, it has a rack of 12, so you can run 12 samples back to back, but it is one sample right after the other. In comparison, the MARS 6 is a batch system where you can run up to 40 samples at a time. So that's a really big difference, okay? And there are advantages and disadvantages to both of these, right? And so what I hope you can see is where, both of these kind of complement each other. Where you've got the MARS 6 and batch extraction, that is going to be great for high throughput, okay? Your bulk of your extractions, the majority of your soil samples. So if you're an environmental lab that has hundreds of samples per day, the MARS 6 is going to be really advantageous for you to get through that high throughput. But the reality is not all samples are the same, right? Maybe you've got that sample that's really high in oil content, or it has a really high moisture content, or maybe it's got potentially some metal particulates in it that wouldn't really lend itself to microwave extraction. That's when you want to think about the EDGE. It's really great for mixed samples. And the reality is we're using a variety of techniques in our labs to get the data for all the analytes we're looking for. And to have a system like the MARS that's going to do the bulk of your work, and then the EDGE is going to be great for those difficult samples, maybe those ones that need a little method development to get the right data, or you've got a rush sample that you've got to get out right that day. That's where the EDGE is going to become really, really handy, okay? And then furthermore, the EDGE offers filtered samples where you don't get that. So some labs are going to be like, oh, I really want to have that filtered sample. The EDGE is going to automate the solvent addition, the extraction, and then get you through the filtered samples, and that's what you want. So then that might be the better option. But another advantage possibly with the MARS 6 is that you can do both extraction and digestion in one system. Now, you'd want to use different vessels, and we'll talk later on about the vessels for extraction. If you were doing digestion, you'd want specific dedicated vessels for that. But the reality is you can do both those techniques in one system. And while I think most of the people on the presentation here today are probably doing extraction, because that's the focus here, you probably got digestion going on in your lab too, whether it's across the hall or in the next building. The reality is most environmental labs are doing digestion as well. So this might be a benefit for an environmental lab as well. So lastly, just wanted to make a quick note that we are following EPA methods across the board, right? Because this is environmental samples, we need to make sure we're adhering to EPA methods. So for analysis, we are using EPA 8270, which is a GC-MS method for semi-volatile organic compounds. So I'm going to dive a little bit deeper into the EDGE first, and then I'll dive a little bit deeper into the MARS. I'm a very visual person, and so we'll go over some videos as well. I just want you to have a good idea of what I'm talking about. So if we dig a little bit deeper into the EDGE, again, it's sequential extraction. I mentioned we have a rack of 12. You can program up to 24 samples, okay? So you can put 24 methods in. At the end of the first 12, it's gonna ding, you just slide your rack out, slide another one in, and then you run your next 12 samples. Per the EPA method, you can do up to 30-gram sample size, okay? And your extraction per sample is gonna be around 15 minutes. And we'll hit how fast that is later on, but it really is the fastest extraction you can get just from point A to point B, having a sample that is extracted. The EDGE automatically adds the solvent, and you have up to 6 different solvent options. That's a big benefit of the EDGE as well. And for the method we're presenting here today, we're collecting 60 mils of extract per vial. Okay, so that 60 mils is what we're going to take, evaporate down, and go to analysis. When I'm talking about the EDGE, I like to talk about in-cell cleanup because it really lends itself well to being able to do that. So while we're not doing much cleanup for the methods we're talking about here today, it's certainly an option. And you will see that we are using some sorbents in a different capacity. And it just, again, if you need to add something in the cell to clean something up or keep something in there, it really just lends itself to doing that easily. And then again, mentioning those filtered samples. That's a really key point to the EDGE, is that you have a filtered sample ready to go to analysis. But I'd be remiss if I didn't spend a little bit more time talking to you about the Q-cup, because the Q-cup is what I feel is really the big advantage, especially compared to other pressurized fluid extraction systems. The simplicity of our Q-cup, which is our sample holder, is really kind of where it's at. And the customers love this because you've got a simple cell, 2 pieces. It is just 1 thread, so it cannot be cross-threaded. As you see pictured there, you just put your Q disc, which is your filtration disc, at the bottom, assemble it, goes together in seconds. And then it's really light. It's made out of hard anodized aluminum. You can put it directly on an analytical balance and weigh your sample in, and then it cleans up really easily as well. So the ease of putting this Q-cup together really is a huge advantage for the EDGE. So now, as I mentioned, I'm a visual person, so let's walk you through a quick video of the EDGE running. So what you'll see in this video is what I just talked about with the Q-cup and how easy it is to put that together. So we're going to grab our Q disc, we're going to put it at the bottom of the cup, and then just screw on. And then we're going to weigh in our sample. Again, you could have put it directly on an analytical balance to weigh that sample. We're going to put it in our rack. We're going to make sure we have a vial present as well to collect our extract. Here you see how easy sliding in and out of those racks really are. So you can be preparing one rack as one rack is running. Couple quick clicks, you load your method, and the edge is going to take over from there. So you'll see the edge again, it runs in series. You're going to take that Q cup and put that sample into the chamber. Back there in the chamber is where all the extraction is going to take place. Once it's back there, your actuator is going to come down. It's going to create a sealed environment. And here's a cross section of what's going on back there. So we now can add solvent from both the bottom and the top. We're going to make sure that the sample is fully wet. And while we do not do bubbling in the method we'll be discussing here today, it is an option. So this video just kind of shows you kind of other options, and that's a great thing about the edge is how flexible it is. So if you choose bubbling, it would bubble at that time, and then it's going to heat and pressurize to a programmed temperature and or hold time. Okay, so you have complete control of that in the method. Once you've reached your temperature and or hold time, it's going to drain through the sample, through the Q disc, through a cooling coil. And so what you collect at the end is filtered and cooled, ready to go for analysis. Another option of the edge is our rinse function, where you add clean solvent and just immediately collect it. So you don't do the whole heating step in that case. But it is a really nice option, and it lends itself really well for a lot of methods. As noted, we are running in series, and when you run in series, you need to be aware of carryover, okay? We don't want to have any carryover, so we're going to wash our entire fluidic pathway with solvent to ensure that there is no carryover. So you'll see the edge doing this here. You just saw it depicted in the graphic, but when the edge is doing the wash, it's going to go over to the wash port, and you see the waste bottle on there on the right. And that needle that just dispensed your extract is the same one that's getting washed, okay? So the entire fluidic pathway is washed with solvent to ensure no carryover. At this point, your extraction's done. So you're either moving on to your next one, or as Brittany is going to show here, for me, I love to do this live, is to show the soil that we just extracted. And it is bone dry. It gives you that feel-good moment that you got a good extraction, and your extract is filtered and ready to go for analysis. So hopefully that gave you a good visual of how the edge runs. So now we spent quite a bit of time on the edge. Let's talk about the MARS. So the MARS, it's a batch extraction, okay? And that's really the bread and butter here, okay? Is the fact that you can do up to 40 samples per batch. We'll talk a little bit more about that batch size as we talk about the vessels in the next slide, but you can run up to 40 samples per batch. Per the EPA method, you can do 20-gram sample sizes. And that batch runs in about 25 minutes. You do have to add your solvent manually for this extraction, and we're adding about 25 mils per vessel. So that's a really good solvent savings there. And I haven't said too much about solvent savings, but in both of these systems, we really are minimizing solvent usage compared to techniques such as SOX-lit or sonication, which can also be used for these types of extractions. And then I want to note the disposable glass inserts, because I think they're a great option for microwave extraction. They cut down on cleaning time, and the customers that I've talked to that are using these just truly rave about them. So I want to spend just a little bit more time talking about the vessels and what I personally would recommend. So the vessels that you will use for microwave extraction are our MARS Express vessels. Okay, we have 3 different options of the MARS Express vessels. We have a 55 mil, a 75 mil, and then we have our MARS Express Plus vessel. And the MARS Express Plus vessel is around 110 mil, so it's the largest of those 3. Regardless of the vessel size, you have some commonalities, right? You're going to have the vessel, which is pictured there. You have a plug, and then you have your cap. You just put your plug on the top, you screw on your cap, and then there's a torque wrench you can use to ensure that that cap is tight. Now with our MARS Express Plus vessel, we have this disposable glass insert option, and that's pictured there. So it literally is just this glass insert that you slide into the vessel. So what this is disposable. So when you're done with your extraction, you just throw it away and you can move on. So it really helps that whole cleaning process post-extraction. Now, when you're doing microwave extraction, you don't want to fill the vessels up all the way to capacity. That's not going to lend itself to good extraction. You want to have about 1/3 of the vessel open. Okay, so what I've got noted here in these vessels, where that sticker is kind of your capacity line. Okay, and first off, I'm going to say the 55 mil. I don't think it's big enough. I don't think that's your right option. Okay, now your 75 mil, that is certainly an option, and it has good capacity for the sample sizes we want to run here. And this is where you get your batch size of 40. In comparison, you have, and the 75 mil, just for reference purposes, that's the tallest vessel. It's the second one in from the right, okay? Our Mars Express Plus vessel is the one all the way to the right. You'll see that it's a little bit wider. And in this case, it fits that disposable glass insert, which is great, but it does minimize your batch capacity. So you would run 24 samples per batch when running a Mars Express Plus vessel. Now, with microwave extractions, per the EPA method, typically you're running a batch size of around 24. So that lends itself well for this application. And so my suggestion is that Mars Express Plus vessel with disposable glass inserts is your best option. And you see capacity-wise, very comparable to those 75 mil. If you look at kind of that glass tube right next to that 75 mil vessel. Okay, so like the Edge, I have a little video on the Mars. Keep in mind, this video is very quick. It's not as detailed as the Edge, but I think it'll still give you a good visual of how the system works, but we are using different vessels than we discussed here. As I noted when I talked about extraction versus digestion, you would use these express vessels for extraction, but you use different vessel types for digestion, and you'll see those in the video.
So now let's talk about the Mars 6. And what I want to bring a little bit of attention to here is the software. It's really user-friendly, and it's the same platform that we use on the Edge. So if you're familiar with the Edge, you can run the Mars and vice versa. So running the Mars is truly as simple as loading your turntable with your vessels, putting that turntable into the Mars, loading your method, hit play, and walking away. It is that simple. So I hope that quick little video gave you a good understanding of how you would run the Mars 6 for microwave extraction.
So before I kind of pass it over to Ben to get into the details, I just want to conclude a little bit about these two systems. We talked individually about the Edge, we talked individually about the Mars 6, but when it comes down to it, there's a lot of things that both these systems offer. And rapid, simple, and efficient. I kind of always throw those together. But if you could take anything away from this presentation, it's that these techniques are rapid, simple, and efficient. And it's true for both of them. They're also both compact size, so they're going to easily fit on your benchtop. They don't need to be in a hood, so they fit well into your lab. That goes into kind of having that nice modern lab. These guys are going to look good in your lab, and they're moderate cost. And I really, again, I feel like they complement each other. There's a lot of things like where the Mars is good, like I said, for that throughput, but you've got those difficult samples, and that's where the Edge is going to really shine. So together, they meet your extraction needs for your environmental lab. So one of the things that I like to do when I do a presentation is make sure I don't gloss over everything. Make sure that we give you all the tools from start to finish. So what I'm going to do now is pass it over to Ben and let him get into those details. And what I hope is by the time Ben's done, you're going to say, wow, I could take this, and if you had the right equipment, I could do this in my lab. Because that's what I want you to be able to do. So with that, I am going to pass it over to Ben to cover the details of what we actually did.
Well, thank you very much for that introduction, Alicia. And like she said, I'll be walking through the rest of the actual sample prep process for both the edge and the MARS samples, hoping to give you guys a more detailed view of that so that if you guys were to run these samples in your lab, you could do it exactly as we have told you in this presentation. So we'll walk through the actual sample preparation on both the edge and the MARS, talking through the actual preparation for both those sample holders. We'll walk through the extraction methods that were run on both those systems as well, then go into a bit of the post workup and how those are going to be different among the two preparation processes. And then finally, we'll go into a bit of the analysis and then actually look at some of the data that we generated from all these experiments that we did. So first things first is for the sample preparation. So we're going to talk about the edge first and then move on to the MARS. So for the edge, we have, of course, the Q cup, which is our sample holder, which is going to be the main component of the sample preparation process. On the left side of the screen, you guys see the Q cup diagram. And for that sample preparation process, what you're going to do first is you're going to take that Q cup, and you have two components of a cylinder and the threaded bottom. What you're going to do is you're going to take the threaded bottom and insert one of the Q discs into that threaded bottom. That Q disc is that inline filtration that Alicia had mentioned earlier, and one of the key differences between the MARS and the EDGE system. For these environmental extraction, we were using the S1 Q disc, which is a sandwich of two C9 cellulose filters that sandwich a G1 glass fiber filter. The glass fiber filter is a 0.3 micron filtration, so it's perfect filtration for any kind of analysis you're doing post-extraction. And the reason we have that cellulose filter sandwiching that glass fiber is that the glass fiber isn't as robust as a cellulose, so it's good to have those as a structural integrity. So after you have that Q disc put into the base of the Q cup, you'll simply assemble the entire sample holder by screwing together along that thread, and that's your whole entire preparation of the Q cup. Afterwards, you'll go ahead and weigh in the sample. For all the extracts and the samples that we ran on the edge, we ran a 20-gram wet soil sample that was mixed with 30 grams of sodium sulfate. You could then spike in any surrogates or standards directly into the sample, into the Q cup. And then the next portion of it is the new change that we've made for the sample preparation process, which is the addition of the 2 grams of fluorosil on top. So that 2 grams of fluorosil, or base-activated magnesium silicate, is really crucial for the SVOCs, especially for those lighter, more volatile SVOCs, and we'll detail that a bit more in the actual data section of this presentation. The final step would be the insertion of a Q screen into the opening of the Q cup, and that Q screen is just the stainless steel mesh that helps to keep any sample from coming out of the Q cup and helps just to keep the inside of the edge system clean. So it's a very simple process, and after you prep that edge sample, you'll then go into the edge running and the actual edge method. So this is an actual screenshot from the edge system itself. And so we'll just walk you through everything that we need to do to actually run the edge method. So on this screen, you can see you have the normal controls for any kind of method. We do have multiple QDIS types. The S1 is our universal filter, but we do have other lines for all your filtration needs, including cellulose and nylon. And now we'll get into the actual meat and bones of the extraction method. So this is the cycles page for every edge method. And you can see that there's 4 different cycles on this environmental method that we're running. You can have up to 12 different cycles on the edge, which just means that there's 12 different additions of solvents in one method. All of these cycles are going to be running with the solvent of dichloromethane, but you have the option of pretty much any organic solvent on the edge, and any other EPA 3545 solvents like acetone hexane or acetone dichloromethane is also amenable and usable on the edge as well. So for every cycle, you have your choice of solvent volume, which is that top volume or the bottom volume. You also have the temperature to which the system heats. That's for 70 degrees Celsius for the first 2 cycles and 100 degrees for the latter 2. You can run anywhere between 30 C all the way up to 180 C on the edge. And then the final parameter you have is your hold time, which is just how long it's going to be holding at that temperature. And so the last portion of every edge method is going to be that system wash that Alicia mentioned earlier. This happens after every sample just to ensure that the whole fluidic pathway is cleaned as well as the sample cell. And this is just to ensure that there's no carryover or cross-contamination. For the wash parameters, you have full control over every variable as well, the solvents, the volume, the hold time, and the temperature, and you have up to 5 different wash cycles in order to get as clean as you need. And so next we'll talk and pivot to talking about the MARS 6 sample prep. They're very similar in a lot of ways, but there are some key differences as well. For MARS 6 sample prep, it is also pretty simple. You would take one of the MARS vessels, one of those tall tubes, and simply add in the 20 grams of sample. And from then on, you can also just spike any surrogates or internal standards right into that vessel as well. The one key difference between the MARS sample prep and the EDGE sample prep is that the MARS, you will need to manually add your solvent, whereas the EDGE, that is automatically done by the system itself. And so for all the MARS 6 samples, we use 25 mils of hexane acetone. The final steps for the sample preparation process would to be to add that plug into the vessel itself, screw on the cap, and then you would want to vortex the vessel to ensure the solvent is fully saturating the sample. If you're using the glass liners, the same sample preparation process follows as above, but you would just add the glass liner and then add all the components into the glass liner. And next, we'll go through the MARS 6 method as well. All the MARS 6 methods for EPA 3546 extraction are one-touch methods, which means that they actually come pre-programmed on the MARS 6 system and have been method developed here at CEM for that specific extraction. Those methods range from 100C all the way to 130C, so you do have a couple options for your actual method for the MARS. And here are just the parameters for that method. I do want to note that one of the key parameters is the power parameter because the MARS 6 is a microwave extraction system, but the MARS 6 is a intelligent microwave system, whereas it will be able to detect what vessels you're using. So if you're using the 75 mil Express or the Express Plus, the MARS 6 will be able to detect what vessel is currently loaded in the system, and then tune the power output for that specific vessels and the number of vessels that you have in the turntable. So that way it just keeps you right at that temperature that this method is supposed to be running at. And so after your samples have been extracted, you need to then go into post-extraction. So for the MARS 6, like Alicia was mentioning, those samples come out unfiltered. On the EDGE, they come out filtered due to that Q cup and the Q disc inside, but for the MARS 6, you're going to need to filter them post-extraction. So here's just the diagram of what we did for those actual extracts post-extraction. We simply took the MARS vessel, decanted off the extract over a filter, poured out the sample into that same filter, and then just rinse with solvent to get any residual compounds or any solvent left in the sample out as well. And then the final steps for that post workup would just be to pour over sodium sulfate if the sample is wet. That's just good practice to remove any water from the extract, and that way you're not injecting any water onto your GC. And then the final step would be just to concentrate your sample down to a known volume in any kind of evaporation system. And here we'll talk very briefly about our analysis. Like we said, we want to be fully transparent with you guys, showing every step that we did along the way for all of the samples. We have pictured our trusty GCMS that we actually use in the lab for all of these samples. And just a quick GC method that we adopted from an Agilent app note that is EPA 8270 adherent as well. And so then moving on, we'll actually get into the data portion of the presentation. So like we said before, we want to be fully transparent about everything that we're showing you guys here. So here are some chromatograms for the EDGE samples as well as the MARS 6 samples. For the spike soil samples, we ran the same thing on both the EDGE and the MARS 6 as in the same sample type. And we just want to share the chromatograms to show you guys what our data look like and that we got clean resolution between peaks, as well as getting a very clean and stable baseline as well. And so now we'll actually jump right into the data. So I do want to mention first about the data that the spiked sample or the spike mixture that we're using was quite extensive. It's over 70 compounds. So the data has actually been split onto 2 slides. And so the order of the analytes are going to be in order of elution from the GC going left to right. So the current slide is showing some of the more volatile SVOCs, some of the lighter compounds. And even for those lighter compounds, we can see that from the data, the EDGE did a good job extracting the majority of the compounds within an acceptable recovery window with tight RSDs as well. There are some compounds, of course, that have some issues detailed in 8270 with issues with reproducibility or chromatography. But for the majority of the part, the EDGE did a fantastic job on the samples. This is in part because of the addition of the fluorosil into the EDGE sample preparation process. Since the EDGE is an open sample cell, some of the lighter SVOCs are liable to be lost prior to extraction, but the addition of the fluorosil layer on top of the sample really helps to retain those lighter SVOCs within this sample itself. And as well as the spike mix being very long, being over 70 compounds, it does encompass pretty much all the SVOC classes and anything that you'll be looking for, such as the organochlorine pesticides, the flame retardants, PAHs, fungicides, and some important compounds that are regulated by government agencies for their carcinogenicity, like N-nitrosodimethylamine or bis-2-chloroethyl ether. And then moving on with the EDGE spike data as well, the same story persists for the latter half of the SVOC compounds, the more heavier compounds, including the phthalates or higher ringed PAHs. You can see that the EDGE did a great job with the heavier compounds, extracting things within a very acceptable window of recovery, as well as obtaining very tight RSDs for these compounds as well. And so moving on, we'll get into the MARS data for the same set of spiked samples and the same spiking compound. And from the data, we can also see that the MARS did an equally good job of extracting those compounds within that acceptable window of recovery and with those tight RSDs as well. The MARS having a closed sample cell design, these lighter SVOCs don't need that additional sorbent to retain the analytes within the cell itself because the cell is closed, which is a big benefit for the MARS sample cell design. And so then the latter half of the analytes, the heavier SVOCs as well, the same story pretty much persists, with the MARS doing a great job on the majority of the compounds with that good recovery window, as well as those tight RSDs. And so finally, we did a spike sample on both the MARS and the EDGE. And we also did a CRM on both the EDGE and the MARS as well. And so once again, full transparency, we want to show you guys that chromatogram for the CRM on both the EDGE and the MARS. Once again, showing that clean resolution between peaks and the minimal baseline and interference. And so here we have the SVOC data for that CRM on both the MARS and the EDGE. I do want to mention that the CRM was also incured as well, so very representative of a real life soil sample. And so the analyte list for that CRM is much less than the spiked sample mix, but still pretty encompassing of all the SVOC classes of compounds. And so here we compare the MARS data in blue to the EDGE data in orange. And like the spike sample data, the same story persists. The recoveries for both systems are in very acceptable windows, and the RSDs are tight as well. I want to mention that the sample prep for the CRM for both the MARS and the EDGE was prepped exactly the same as it was for the spiked samples, following the process that we detailed earlier in this presentation. And so before I want to pass it off to Alicia to finish out the presentation, I hope you guys were able to see the simplicity in the sample prep for both the EDGE and the MARS, just hitting on how simple both those systems are to both prep the samples as well as run. And I'll go ahead and pass the presentation back to Alicia to have her finish it out.
Thank you, Ben, for covering all those details for us. I truly hope, as I said before we got started, you feel as if you could take that information, and if you had the right equipment, you could run those methods. So with that, I want to spend a little bit of time on the collateral and support that CEM has to offer you. All right, so everything that Ben just discussed is in an application note. So you can go to our website, you can download that information. You can also see all of the application notes that we have to offer beyond this sector. But specifically the data here today, there is one application note dedicated to the edge and one application note dedicated to the MARS. And I have to take a step back here because I just kind of got right into this, and huge thank out to Ben who ran that data. Okay, so that's very relatable in the fact that he's the one actually running these two techniques. So if you have any questions on just what is and really in the lab running it, please reach out to Ben because he's going to be able to talk to you from a realistic point of view because he's the one that prepped all of those samples and generated the data that was presented here today. So to continue to kind of call out Ben, I want to talk a little bit about Willet Extract, who Ben is our star, and he has, I think he's adapted well to that role. If you have not watched Willet Extract, I encourage you to go to our website and check it out. We have a number of different episodes, and our soil episode, very applicable to this presentation, was just released soon. I actually, maybe as I speak. So I really encourage you to go check that out, watch some of the Willet Extract. They're kind of a very light and humorous way of looking at some complicated problems. And I hope they give you some good tips on how to do this extraction on the edge. And then if you want more details, you can always come and read our application notes, which are going to give all the details about the method and the data. So while I'm kind of still focusing on collateral and support, I want to talk about the fact that CEM is here to assist you, okay? So here you've got a picture of the United States where it shows we have 60 associates in the United States and Canada, 24-hour telephone support, and that's mainly for service and tech support, but we are here for applications as well. And at the very end, I'm going to have an email address put up. You guys can reach our team with any applications questions. One of the things that I'm really proud about working for CEM is our customer support. When we say that we're here to assist you, we truly, truly mean it. Now, I know that there's a large part of this audience that is international. So when I say that we are where you are, I mean that on a global scale. Okay, I field emails globally daily, and I love it. I want to be connecting with you guys. I want to be answering your questions. And even if it is something that is, you just have a question about a technique, or you have a question about service, or you have a question about an application, please reach out. We are here to assist you, and no matter where you are in the world, that remains true. We are where you are, and we are here to provide you confidence and good methods so that you can get your work done. So with that, let's conclude about the techniques that we've talked about here today. So rapid, simple, and efficient. I told you that I was going to mention that again because it's important. Like I said, if you take anything away, I want you to take away that it's rapid, simple, and efficient. And that is true for both of these systems. And if we dig in a little deeper, let's talk about it. Rapid, okay, you got the edge, which is the fastest extraction that you can do. Okay, think about it, 15 minutes, you have a sample that you can put on your GC. So you shoot it on your GC, 20 minutes later, you have data, okay? In a very, very short time frame, less than an hour, you are making decisions. You have data and you can move forward with whatever you were trying to solve at that moment in time. It is truly the fastest start to finish data that you can get working with on the edge. On the other side of things, the MARS is the fastest batch extraction available. Think about that. 25 minutes, you got 40 samples you can start working up to get to analysis. So I hope that it's really clear that we are offering you a rapid solution here for both of these systems. So if you think back to that pie graph in the beginning, think about what we can do. We don't have to spend 62% of our time on sample prep. We can truly minimize that time and make it faster. And we have two options here that do that. So simplicity. I hope you saw from start to finish with both these systems how easy they are to run. And one thing that I don't have noted here, but the software. Software is really easy to use, it's user-friendly, and same platform for both, right? So if you're familiar with the MARS, you're gonna be able to run an edge and vice versa, okay? But specifically for each system, I hit upon it, the Q cup is all about what the how the edge is simple, right? Q cup is so easy to use, so easy to clean, and it's really a unique thing about that particular system that kind of bring home the simple concept. Where on the edge, you've got that easy to use disposable glass insert. And for the same thing, unique to the system that brings home, this is an easy to use thing. It's gonna minimize on your cleaning. So across the board, again, regardless of which system you're using, simplicity is where it's at. And then lastly, efficiency. So for both these systems, we're talking about automation. And when you talk about automation, you are removing the human aspect, you are gaining efficiency. So particularly on the edge, where the system is taking care of the solvent addition, the extraction, the filtration, the cooling, the washing, all of it's automated. You are going to get better results out due to that automation, due to that better efficiency. You're going to have better reproducibility. And then think about that. I have the reproducibility noted over there on the MARS because you've got 40 samples that are put into the exact same environment. Okay, so you are truly getting very good, tight, reproducible results because you're applying the same exact conditions to all the samples in that batch. And then for both systems, when you move into automation, you open up the ability to have traceability, okay, reporting. And that's not true for all sample prep techniques, okay? If you're doing, benchtop work, you don't really have traceability there. And for the modern world, traceability is so important. We need to be able to go back and see exactly what we did. And each of these systems are going to be able to give you reports to say exactly that. So I hope that, if anything, you can see that these systems are rapid, simple, and efficient. And just kind of conclude, and they're complementary. Go back to the fact that the MARS is going to take care of the bulk of your samples, and then you've always got those little kind of one-offs, those hard ones, and that's where the edge is going to shine. So no matter what your lab needs are, I hope you see, whether it is one system or the other or both, we have an option to fit your needs. So again, I told you I'd give you this email address. It's molecular.support@cem.com. I want to see you reaching out to me. The people behind this email are pictured here. You have myself, I am the lead R&D scientist. You have Dr. Candace Cashman, she is our senior scientist. You have Brittany Leffler, who is our product specialist. And you heard today from Benedict Liu, who is our application scientist. And I'm telling you guys, these guys are experts. No matter who you get, they're going to be able to answer your questions. I am so proud of this team. And I think that if any of you guys in the audience know these people, have worked with them, you would 100% fully agree with me. We have a great team here for the edge and microwave extraction, and we can't wait to get to know you and answer your questions and solve your needs in your lab. So with that, I am going to pass it back to Leanne.
As Alicia and Ben have mentioned, if you have any other questions for Ben, Alicia, or the rest of the molecular extraction team, please contact them at molecular.support@cem.com. Thank you and have a great day.
Thank you. Bye.
Thank you.